Regarding future treatments for Parkinson's disease, there's a lot going on right now. For purposes of this video, I'm just going to break it down into two main types. One problem that we've been grappling with for decades is that over time, patients find that their levodopa lasts a shorter and shorter amount of time. So they'll take their levodopa, it'll start working, and then after a few hours it'll wear off. And what we really need is a medication that provides a very good response quickly and then lasts for a very long time, maybe through the day. Levodopa is a very difficult substance to work with, and in the bloodstream it only lasts a long time. So this has been quite a challenge, but a lot of headway is being made in this area. One thing that many pharmaceutical companies are working on is a long-acting levodopa formulation, an oral formulation, so that you could take a levodopa pill and in one way or another have it last a longer amount of time. There's one of those in front of FDA right now, and there's some more behind that are being developed. The one that's in front of FDA is probably a 3 or 4 time a day pill. Those that are being developed behind it, a 2 or 3 time per day pill. So there's definitely on their way long-acting levodopa formulations. In addition, there is an inhaled levodopa formulation. It comes in a little inhaler that almost looks like a kazoo. And the idea here is with an inhalation, it gets into the bloodstream and up to the brain relatively quickly, and then it may last perhaps 90 minutes. And the idea is if your oral levodopa starts wearing off, you may be able to take a puff of the inhaler and then have your response bridge over to the next oral levodopa response. So it kind of fills in the potholes, is a common saying these days, so to help smooth out the response. So between long-acting oral levodopa medications, other medications that are developed to smooth out the response, and things like the inhaled levodopa, I think we're making a lot of progress over the next 3 years, 5 years to get patients' response smoothed out. Now, the other area that I think is just really starting but really exploding is slowing progression of disease, and things have really changed from 10 years ago or even 5 years ago. And that's because we know so much more about how the disease occurs and how it spreads through the brain. And the basic story is that we know that a protein in the brain and in the body called alpha-synuclein normally exists in little curlicues and kind of unfolds and folds, unfolds and folds. And sometimes when it unfolds, it can meet a neighbor and they can stick together. And once that happens, they can't refold. And when they're unfolded like this and stuck together, they can find another neighbor, or another neighbor can find them, and they start forming these sheets. And not only that, but they can travel from cell to cell and then spread through the brain. And this process then is protein aggregation and templating with the propagation through the brain. And that appears to be at the core of Parkinson's disease. There's a lot of details to be worked out. Why does it happen in some people and not others? What part of that process causes dysfunction of cells or death of cells? So a lot yet to be worked out. But just knowing that that's at the heart of Parkinson's disease opens many, many avenues for treatment. So for example, we know that if one has too much alpha-synuclein, that sets one up at risk for this process of protein aggregation. So there are therapies in development that will lower overall alpha-synuclein in the brain. There are other therapies that, at least in the laboratory, reduce the number of alpha-synuclein proteins that come together and clump up. So reducing this clumping process or aggregation process is a very active, very hot avenue of research that's underway in laboratories and academic centers across the United States and the world. In addition, I mentioned that this happens in one cell, and then you get sort of a little seed that comes out of one cell and then goes out and comes into another cell. Well, there are opportunities to either prevent it from going out of one cell or capturing it as it comes out of one cell before it can get into the next cell, or preventing it from getting into the next cell. So these are therapies that prevent the propagation or spreading of this protein aggregation process. So all of these therapies are now in laboratories and beginning to be evaluated. One of these therapies is a vaccine approach, which a lot of people have heard of. So far, very early studies on the vaccine approach show that it appears to be safe, and there's some suggestions that perhaps there's something there, but it's still very, very early. But the vaccine approach is one approach to trying to slow or stop this protein aggregation and spreading of the protein clumping through the brain. So those are two very active areas, and I think we're going to see a lot of changes over the next few years. I think we'll be able to smooth patients' response much better in the next 5 years, and over the next 5 to 10 years we're going to see a lot of work in slowing progression of disease based on our understanding of alpha-synuclein aggregation and propagation through the brain.